let's jump right to the end. If you were given 10 tries to guess the code, what would be the probability of guessing the correct code? Okay, so we got some sort of code. We got to guess a probability. It sounds like we're going to have to figure out the number of different options there are for this code. So with that in mind, now let's go read through, and now the details of the problem will hopefully stick in our brain a little better. Numbers from 0 to 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 digits we can choose from, including 0. So 10 digits are selected at random and combined to make a code that contains a 6-digit number. Numbers can be repeated. So there's 6 digits, 1, 2, 3, 4, 5, 6, right? How many different ways are there to pick the first digit? There's 10 different ways, right? If we use the fundamental counting principle, there's 10 different ways of picking that second digit because we said numbers can be repeated. So this third digit could be a 0, 1, 2, 3, 4, 5. There's 10 different ways of picking the third one. And I think you get the idea. 10 here, 10 here, and 10 here. So for the 6 digits, there's 10 options each. So to find out the number of ways we can make that 6-digit number, we have to multiply the number of options for each of those. So it's 10 to the 6, right? So this is 1 million different ways of making this code. So if you're given 10 tries to guess the code, what's the probability of guessing the correct code? Actually, let me think here. I think if you were to eliminate your guesses, so you make your first guess, now there should be only 999,999 options. I don't think Newton wants you to do that because that's going to be a really painful fraction. I think all they want you to say is there's 10 guesses out of 1 million different possibilities, right? Because a probability is found by taking the number you're interested in, the number of guesses, and dividing it by the total amount of options. So if you simplify that, that's just 1 out of 100,000. There's 1 out of 100,000 different ways. Oh, and they want it as a fraction, so we'll keep that there. Let me just punch this in to make sure. Yeah, and the stuff I was musing about, this is the probability if we assume the 10 tries to guess are all random, so they could repeat. If they don't repeat, then it's actually slightly different. So I think that question could have used a little bit of extra detail, but okay, yeah. So that's kind of a trickier one. Let's see what other types of problems we have in this section. This one's kind of the same idea. It's going to be a slightly different calculation though. We have how many different ways can a 4-digit number? So 1, 2, 3. There's 4 numbers in our final number. A 4-digit number. We only have the digits 1, 2, 3, and 4 to play with though. So we don't have all 10 digits. We don't have 0, 1, 2, 3, 4, 5, 6, 7. We just have these 4 to work with. So how many different ways can you pick that first digit? There's 4 different ways of picking it. Now how many different ways can you pick this second digit if we've already used the 4? You know, we've already picked out like a 4. Or it could maybe, actually I shouldn't write down the 4 here. Yeah, it's kind of confusing because there's 4 numbers. Oh man, I can see how this is going to be confusing for a student that's just getting used to these. So I'll make sure to do another example after this one. There's 4 different ways of picking this first digit, okay? It could be a 1, or it could be a 2, or it could be a 3, or it could be a 4 that goes here. Okay, so that 4 doesn't represent the digit that we're plugging in. It represents the number of different ways of picking that first digit. And given that we've already picked this first digit, let's say we chose randomly and we chose the first digit was a 1. Now, how many different ways can you pick this next digit? The 1's gone, right? Because we're arranging these digits. So the 1 is already used up. There's 3 different ways of picking this next one. Let's say we picked randomly and we got a 4 here, okay? The black numbers can be replaced because there's a lot of different other combinations. This is just one particular example. For the second digit, there's now 2 numbers to pick from for the second one because we scratched out the 4. And for this last digit, there's only one way of making that happen. So this represents the number of different ways of picking those 4 digits. 4 times 3 times 2 times 1. So 4 times 3 is 12. 12 times 2, that's 24. A track race has 9 participants. And how many orders how many orders could the runners possibly finish? So like first, second, third, fourth, fifth. Let's call them the 9 people. Type this. No, of course I can't type it. We'll call the people A, B, C, D, E, F, G, H, and I. Those are the people's names, okay? That's one order, right? Or you could switch it up. You could say A, C, B, D, E, F, G, H, I. There's a lot of different ways you could order it, so we obviously don't want to try to count them all out. So if you start like we did the other problems, how many different ways could they finish? How many different ways could we have a first place finisher? How many different ways could we randomly pick this first person? There's 9 contestants, right? So there's 9 different ways of having a first place finisher. And let's say that first place finisher was the person named B. How many different ways can the second place finisher come in here? Since B has already been chosen, now there's 8 different ways. And since let's call this C. Now that B and C have been chosen, now there's 7 different ways. And you can see actually this is just going to be a factorial, right? This is 9 factorial all the way 9 times 8 times 7 times 6 times 5. And so if you calculate that, 362,880 different ways that those people could finish the race. Whoops, watch out. I circled the million one. This should be, that's 3 million. The correct answer was 362,880. So, man, that looks like just a trick answer. Just be careful about that. Make sure to do exactly what your calculator says.